In this example, we're going to solve a logarithmic equation. Step 1 to solving a logarithmic equation is to rewrite it in exponential form. So recall the snail-like pattern or counterclockwise type circle. So we're going to move and say x raised to the third power equals 8 over 27. So that's our equation. The next step to solving this equation, I want to solve for x. And right now, x is cubed. So the opposite of cubing is to find the cube root. So in order to solve for x, I'm going to have to find the cube root of that left side. Now you know the rules for equations. Whatever you do to one side, you must do to the other. So I'm going to have to find the cube root of both sides. So now that I've done that, you notice the left side is going to just simply equal x. And so now we need to find the cube root of 8 over 27. And we know that's going to be 2/3. And there you have it. That's our solution. And we've just solved a logarithmic equation. Let's check our solution. We can check our solution if we said that x equals 2/3. All we have to do is remove the x from the original equation and replace it with 2/3. Now let's do the math. Again, we're going to rewrite it in exponential form in the snail-like or counterclockwise pattern. So that would be 2/3 cubed equals 8 over 27. And that is correct because when I multiply the number 2 3 times, I get 8. When I multiply the number 3 3 times, I get 27. And so there you have it. It does check that our solution is indeed 2/3. In this next example, we are given the log base 4 of x equals 5/2. So again, step 1 would be to rewrite it in exponential form using the snail-like or circular counterclockwise pattern. So that's going to be 4 raised to the 5/2 equals x. So here we want to solve for x. X is already by itself. All we have to do is just simplify our answer to the left. And again, whenever you have a number raised to a fraction power, a rational exponent, you can rewrite that in radical form. So under the radical symbol, I'm going to have the base of 4, the number 4. Notice the top is a 5, so I'm going to raise it to the 5th power. And what root is it going to be? Notice the bottom. If you said square root, that's correct because you have a 2 in the bottom. 2 as an index means that it is square root. So let's go ahead and rewrite this rational exponent into radical form. The square root of 4 is 2, and then we're going to raise 2 to the 5th power. So when you multiply the number 2 5 times, that will give you an answer of 32. So x equals 32, and there you have it, solving a logarithmic equation. Solving logarithmic equations. So in this example, you'll notice that it is written a little different from the previous problems we've worked. It is the same thing. You just have the x on the left side this time instead of the right side. So instead of moving in a counterclockwise pattern, you're going to move in a clockwise pattern. But you're still going to, step 1, rewrite it as an exponent. So we start with our base. Our base is 12, and you say 12 to the x power equals the cube root of 12. So let's go ahead and rewrite that. Next, I want to rewrite the right side as a rational exponent. So right now it's a radical, and I want to do the reverse, which is write it as a rational exponent. Why? Because if you notice over here, you have a base of 12 to the left. So we can write the right side also as having a base of 12. So that would be 12 as my base number. You'll notice it's not raised to any power, so the numerator I would have a 1. The root is cube root, so that would go into your denominator. So what you would have is 12 raised to the 1/3 power. And notice now that they have the same base. And recall the property of equivalence with logarithmic functions and exponential functions, that if the base is the same, that all you have to do is set the exponents equal to each other. And so when we set our exponents equal to each other, we see that x equals 1/3. And there you have it, solving logarithmic equations.